video I will be covering binary conversions both from denary to binary and from binary back to denary. Denary being the normal number system you're using ranging from 1 to 9, and binary being the computer mathematical system using zeros and ones. It's important to remember the order in which these numbers go. Just simply remember that it starts at 1 and doubles its way up. You can go up to as many as you want. I've gone up to 512, normally only see it go up to 128. However, I thought it was important to show that it just keeps doubling afterwards. So there's 2, 4, 8, 16, 32, 64, 128, 256, 512 onwards. It's also important to remember it goes from right to left rather than left to right. If it's going the other way, you could end up with the correct result, however, it would be in the wrong order and the examiner may not understand your workings and you may lose marks due to that. So, as you can see by the question on screen, it's telling you that an alarm clock is being controlled by a microprocessor, and that it uses a 24-hour clock system. It's important that all the information of the question is read, as parts such as the 24-hour clock system will become useful later on when we have to actually do the conversion. It's telling you that the hour is represented by an 8-bit register. This is normally binary is done using 8 bits, although in some questions, as we'll see later on, they don't use 8 bits. They will range from 9 bits to 10 bits depending on the size of the number. It's also telling you that the other side, the minutes, is also using an 8-bit register. This is also common if one side is using, let's say, a 9-bit register, the other side will use a 9-bit register. So it's telling you, this question A, to identify what time is represented by the following two 8-bit registers. So it's given you the numbers that go into the binary, the zeros and ones. So if we go over to our binary chart at the bottom of the screen and we put in what they have, which is 1 in the 16 column for the first section and a 1 in the 2 column for the first section, we can see you get a total of 18. So if you were going to do this without a chart such as this, you would take that 16 and that 2 and add them together, as a 1 denotes that that's positive. So we can think of it as true and false. So 0 means it's not being used, but 1 means it is being used, showing us that if there's a 1 in the 16 column, we have the number 16, and as there's a 1 in the 2 column, we also have the number 2. So to find the result, we simply add those together, and we have the hours of 18. Now if the question was to say that there was a 12-hour clock system in place, we would have to convert the 18 to the 12-hour clock variant, being 6. However, as it's 24-hour, we can put this number in. So now we've done part A, we can reset this chart, which I will do shortly. And now it's part B. So for the second part of this, we can see we've got a 32, a 16, a 4, and a 1. So if I add this into our calculator here, you get a total of 53. Now this can be done. This is done exactly the same way as the first one, just adding the numbers together, and you just put 53 in the answers. Now we shall move on to the next bit, part B of this question. It's telling you that an alarm has been set for 07:30. Keep in mind that this is still using a 24-hour clock, as you can see by the 07 used rather than just the number 7. Also the lack of an AM or PM indicator. It's telling you that two 8-bit registers, C and D, are used to represent the hours and minutes of the alarm time. And it's asking you how 07:30 would be represented in these two registers. Now, what's important to keep in mind is, well, the other time we were simply putting the numbers in and getting a total. This time we're going to have to calculate what's needed to make those numbers. So, to make a 7, the way I always learned how to do it was to take the biggest number you could that was closest to it. So we can't go with 8 because it's 7, but we can go with 4, and it gives us 4. We can also go with 2, because 2 add 4 is 6, and then simply add a 1 to that, and you've got your 7. So now we've worked out our number for the 07, we have to work out 30. Now, even though the 30 is a bigger number, it follows the same premise. So let's add on the biggest number we can, which is the 16. And after that, we will add on an 8, because 8 plus 16 is 24, it's not more than 30, so it will go into it. Then we can add a 4, taking us to 28, And to get it to 30, all we simply need to do is add a 2. And that would be our 8-bit binary number for the register of D for that question. Completing that question hopefully with full marks once all of this is correctly solved. You've got the correct binary numbers. Now I hope this video has been helpful and helps you understand a bit more about binary conversions, both from denary and from binary to denary today.